Now we start a new article and it is coefficient of coupling. Now what is the coefficient of coupling? Basically it is the fraction of magnetic flux produced by current carrying coil, current carrying one coil linked with other coil is called as coefficient of coupling. Coefficient of coupling. So pay attention here. So when the current is passed through one coil, the magnetic flux is produced by the one coil. Then how much the magnetic flux of one coil is linked to the other coil is the coefficient of coupling. Now see here, the magnetic flux of coil 1 is 100% linked to the coil 2. Then we can say that coefficient of coupling is 1. The maximum value of the coefficient of coupling is 1 if all the flux, magnetic flux of one coil linked to the other coil. Then this coefficient of coupling is 1. And it is called as perfectly coupled coils. It is called as perfectly coupled. As well as if the coefficient of coupling, generally if it is greater than 0.5, if coefficient of coupling is greater than 0.5, then it is called as tightly coupled. Then it is called as tightly coupled. And if this K less than 0.5, then it is called as loosely coupled. Okay. Now here, let's see a coil. Then I can write here mutual inductance of coil 2 with respect to the coil 1. Mutual inductance of coil 2 due to the current in coil 1. It is given by formula. So we have one formula which we learned in the previous article. This N into phi is equal to this M into this I. By using this formula we can write N2 into phi 2 divided by I1. And mutual inductance of coil 1 with respect to the coil 2 is N1 phi 1 divided by current 2. Hence, here I can write M21 multiplied by M12. Mutual inductance of coil 2 with respect to coil 1 multiplied by mutual inductance of coil 1 with respect to 2 is equal to N2 phi 2 divided by I1 multiplied by N1 phi 1 divided by I2. I can write this I2 to this side and I1 to that side. Then we get N2 phi 2 divided by I2 multiplied by N1 phi 1 divided by I1. So this I can write L2 and this as a L1. So here we get M21 multiplied by M12 is this. Now we consider here let M21 and M12 they are equal, then is equal to M I can write here. Then hence M into M square is equal to L1 multiplied by L2. So here we get M square is equal to L1 multiplied by L2. So I can write the same formula. Hence M max is equal to root L1 L2. So this is the value of maximum mutual inductance under root L1 L2. In general, I can write in general also. This mutual inductance we can write K under root L1 L2. And this K is coefficient of coupling. Coefficient of coupling. Now here you remember one thing here. We can write some special cases. for perfectly coupled coils, K is 1. Means this is the maximum mutual inductance we get for perfectly coupled coil. Tightly coupled coil, tightly coupled coils, K is greater than 0.5. And the last case we can say that for loosely coupled coils, K is less than 0.5. So you remember here coefficient of coupling is 1. It is perfectly coupled coils, greater than 0.5, tightly coupled, less than 0.5, loosely coupled. But here generally we cannot observe perfectly coupled coils. Means K cannot be 1. By practically K cannot be 1. We are not getting perfectly coupled coil. So this is the coefficient of coupling article. I hope everyone understood this.